Alright, so in this video what we're going to look at is how to find the value of a bond. So let's take a look at our problem. For this problem, our question is this. What is the present value of a 20-year bond with an 11% annual coupon rate, which makes interest payments semi-annually if the par value is $1,000 and the applicable annual market rate is 7%? So we have a 20-year bond with 11% annual coupon rate, which makes interest payments semi-annually, and the par value is $1,000 and the applicable annual market rate is 7%. So before we proceed any further, my recommendation is that you evaluate whether this bond should sell at a premium or a discount. And here's how we do that. We know that the market rate is 7%, and we know the coupon rate is 11%. So if I compare the coupon rate to the market rate, it should tell you whether the bond is selling at a premium or a discount. So at this point, I recommend that you pause the video for a moment and evaluate whether this bond should sell at a premium or a discount. Okay, so if you pause the video to work this out, what you should have arrived at is the conclusion that because the coupon rate is larger than the market rate, in that case, this bond should sell at a premium. So we should arrive at a price for this bond that is larger than the par value by the time we're done, if we've done this properly. So now what we need to do is write down our inputs. So they're the familiar inputs that we've been working with for a while now. So we have N, I, PV, FV, payment, and type. And as usual, NI and payment all have to connect to the same period of time. So notice that in this case, it is stipulated that this bond is making payments semi-annually. So if it's making payments semi-annually, N needs to be the number of semi-annual periods. Now, there are 2 semi-annual periods per year, and there are 20 years for this bond. So we need the total number of semi-annual periods. So to find that, we're going to take the 20 years and multiply that by the 2 periods per year. So 20 times 2, which gives us 40. So there are 40 periods for this bond. Now I needs to be the rate per period. And if you're using your calculator, note that I is expected to be in percentage format. And when you are discounting the cash flows from a bond, you always use the market rate. So the annual market rate is 7%. So we need the semi-annual market rate. So we'll take 7 and divide that by 2 in order to get the semi-annual market rate, because we're going to discount using the market rate. Now, what we're asked to find is the present value. So present value is what we don't know at the moment. Future value is going to be the cash flow that happens at the end of the 20 years. And specifically, that's not associated with the interest payments. So in this case, what we have for future value is this par value of $1,000. So I'm going to put that in as a positive $1,000. And our payment represents the coupon payments that we're getting every period. And how long is a period? It's semi-annual. So it's the semi-annual coupon payment. So to find that, we would take our 11% in decimal form, so 0.11, times our par value of 1,000. So 11% per year times 1,000 would give me the annual coupon payment, but they make payments semi-annually. So I would take that and then divide it by 2, and then that would give me the payment per semi-annual period. At this point, I recommend you pause the video for a moment to work that out and to see what you get. Okay, so if you took a moment to work that out, what you should have arrived at was a semi-annual payment of $55. Okay, so we're getting $55 per 6 months. And for a typical bond, it will make payments at the end of each period. So in the absence of any information to the contrary, we're going to assume that since this is a bond and the bonds typically make payments at the end, we're going to assume it makes payments at the end. So we'll set the payment type to end. So at this point, we have all of our inputs. N is the number of semi-annual periods. I is the market rate per semi-annual period. This is the payment per semi-annual period. The future value is put in here as 1,000. And notice that I'm using a positive value for future value and a positive value for the payment, because if I bought the bond, this would be a cash inflow to me, and this would be a cash inflow to me. So both are going to have the same sign, which is positive. So at this point, you should move your cursor up to the present value line in the time value money solver, hit the alpha key, and then enter, which is telling it to solve, and see what you get for the present value. So I will wait a moment to allow you to pause the video in order to see what you get when you work it out. Okay, so if you pause the video to work this out, what you should have gotten was a negative $1,427.10. And that would be the present value or the expected price of this particular bond. Now, notice that your calculator gave you a negative sign, which you have to interpret with a grain of salt. So the present value of the bond in this case is $1,427.10, which is, lo and behold, a premium because it is over the par value. So that works out the way that we predicted that it would, and that's good. So now we can also work this out if you try this in Excel. So the way you would set this up in Excel would be equals present value, so equals PV, and then you'd open parentheses, and the first argument you need to put in is the rate. So in this case, we do 7%, you would need to put the percent sign in there, divided by 2. So you either need to put the 7 and the percent sign divided by 2, or you need to convert this into decimal format, so 0.07 and then divide by 2, or actually work that out and put the number in. Then the next thing that it is asking for in this particular formula is it is asking for the number of periods. So for the number of periods, we could do 20 times 2, which is of course 40 periods. The next thing that is asking for is the payment per period, which we found up here, and that's 55. And then the next thing it asks for, it's technically an optional argument for Excel, but you would need to include it for this scenario, and that's the future value. And we do have a future value, so we definitely need to include it. So we include the future value of $1,000. Now you can optionally put in a type to tell Excel whether this is an ordinary annuity or an annuity due, but it will assume it is an ordinary annuity if you don't tell it anything, and it is an ordinary annuity, so we can just leave that off. Notice that the payment and the future value have the same sign, which is important in order to get the right result. So if you try this in Excel, you should get a number. So at this point, I recommend that you pause the video, try this in Excel, and see what you get. Okay, so if you pause the video and tried that in Excel, what you should have gotten is negative $1,427.10, which is what we got before, so that's good. But then notice that we've got this negative sign here. So if you're doing this in Excel and you wanted this to be positive, what you would need to do is insert a negative sign here in your formula between the equal sign and the PV, and then that would give you a positive result of $1,427.10, which matches what we got up here as our answer, and it is of course still the premium, which is what we determined that it should be. And that is how you find the present value of a bond. I recommend that you try some other examples and see how you do.